Welcome again to chemistry lesson, and this time around we are talking about writing of chemical equations. It's my hope that you will enjoy the lesson and also you will learn something. After watching the whole of this session, you will come out a better person as far as chemistry is concerned. I want us to learn about writing chemical equations. As I said, and I've been always saying this in many of my lessons, that if chemistry actually involves chemical equations, if you can master the art of being very sure of every kind of a chemical equation, then I'm telling you, your chemistry will be up. Just start with this. Ensure you are perfect as far as writing of chemical equations is concerned, then every other thing will be very simple for you. Because after writing a chemical equation, always what follows down there is you give and explain the observations. But if you don't know the chemical equation that has taken place, then now tell me, which observations will you give? Which explanation will you give? So the first thing is, learn how to write chemical equations. And I always say this, there is no topic without requiring you to write chemical equations. I'm talking of the serious chemistry, that is from 2, chemistry and above. Now, if you want to write a chemical equation, there must be 2 species or substances or elements or compounds that are reacting to give other products. So using A and B, for example, I've written here A plus B, then an arrow. It means what? A reacts with B. This addition sign in chemical reaction stands for react with. The arrow is to give A and B react with B to give C, or C and D. Then, though you know what you've always been saying, A plus B. That is the case, then the answer should be AB. Or A plus B on that side. But now, because A reacts with B to give C and D. Let me concentrate here for a moment. There are 2 types of arrows. There is an arrow that will show you that this reaction is reversible, meaning it can proceed forward, again it can proceed backward. C and D can react to give A and B, A and B can react to give C and D. If that is the case, then I will change my arrow. I will use what you call half arrows. If at all this equation is reversible, that's what I will use. If it is irreversible, I will say A plus B to give C plus D. That is the equation of the reversible process. You can't reverse the process back. But in most cases, we are going to learn about this. And that's it. So, any species, elements, compounds, or whatever, before the reaction sign are referred to as the reactants. Then we have the products on the other side. And writing of chemical equations is always very simple, or it will be simple, as far as you know how to project the products being formed. In Form 1, you are taught about a word equations, whereby you write in form of a word. Metal plus acid to give a salt and hydrogen gas. No one will require you to give the chemical equations, but now that is where we are today. But the good thing, the Form 1 chemistry taught you this. It made you project the products formed. Even if you know how to write the chemical equations and you don't know the products being formed, then it is useless. In Form 1, the following things you are being taught to protect. In the topic of air, and combustion, you are able to get and know that a metal and oxygen would give us a metal oxide. Then after this, we will learn how to write now in form of a chemical equation. The same topic you learned about a metal and a nitrogen gas. What do you get? Back, as its bases and indicators, you learned, in fact, that is where you learned most of the word equations. Whereby, an acid can react with a metal, can react with a base, and it can react with a carbonate. And all of them, you are being given the products. So, first of all, you need to project this. You should always be at a standby, knowing in your mind, what are the products formed? Is there water? Is there no water? Those are some of the things. If you don't know the products from them, my friend, whatever we are going to learn right now will be a problem to you. And Form 1 chemistry gave you several projections. Ile the projection now, whatever is going to be formed is this. Can do a metal and an acid. You are going to get a salt and nitrogen gas, a metal salt, that is, an acid and a base, because the two of them are, acid and a base, so they are going to neutralize each other, and then you will get neutral products. And the neutral products are water and salt. Then when we talk about a carbonate and an acid, whatever you will get there, you will get three products. First of all, where we have carbonate, there must be carbon dioxide. There must be a salt there because of the acid. And then there must be also water. So you see, when you know what is being formed, it becomes simple for you to write. Again, in Form 1 still, you are able to get what are the products formed when water and a metal react. Gives you a metal hydroxide and nitrogen gas. Again, you are able to get very well. There are some metals that do not actually react with water directly, but they react with them in form of a steam. Steam. You know them. You know even the special case, that is where you don't need to forget. The special case of iron with steam to give tri-iron tetraoxide. Try to put down in form of a chemical equation. Do all of them. I was doing this with some of my friends, high school friends. I just told them, can you go back to your high school notes, Form 1 note studies, write all the word equations, then rewrite them now in a chemical equations. Go at the days. If you are informed now, let me show you this. You will never get any paper telling you to write a word equation. It's like you are above 10 years and you are being told to use diapers. It can't. Kutana na swali ya Form 2, Form 3, Form 4, a word equation. That's not a serious paper. So, my point is this. Let's learn how to write chemical equations. And whenever you are writing chemical equations, there are things you need to know. Of course, you are given the reactants. These are the reactants. Products. We always give you the reactants. Now, give us the products. So, the first thing is, you should know the products being formed. And that one, it needs you to be very serious. Yapili. After knowing the products, remember we have 3 states of matter. We have solid, liquid, and gas. Then we have another one that I'm going to add you. When a substance is in form of a solution form, we say the state table is aqueous. Always abbreviated as AQ. Not KQ, I'm saying AQ. Soma, the window band the KQ. So now, if that is the case, we have to assign A. If it is liquid, you write L. in brackets upper. If it is solid, we write S. If it is aqueous, we write AQ. All true. So again, you should be in a position to know the state symbols of various elements and compounds, both for the reactants and products. Then, after that, there is what we call balancing of the equation. You balance the number of atoms on the reactant side together with the number of atoms on the product side. Writing of a chemical equation up to the end without balancing is like the way I'm shooting this video. I shoot it up to the end, then I don't record, I don't save. That is, I don't save. It will be useless. So that when you unaandika equations now you don't balance, you don't write, just leave it blank because it adds no value. Now, starting with the simple ones. And this is now where the issue of chemical formulas comes in. You should be knowing how to write chemical formulas. I want to pick a metal and oxygen. Then we see how to write chemical equations of such equations. Now, let me start with the simplest one. Every Kenyan student, including you, knows that there is a metal known as sodium that always reacts with oxygen. That is sodium. Sodium is a solid. Now reacts with oxygen. We know the chemical formula, the chemical symbol for oxygen is O. But look here. I'm writing O2. It's a gas. To give us, why am I writing O2? Oxygen is one of the gases that exists as a molecule. It's a molecular substance. So what do I mean? They exist, not singly, but they exist when they are paired. Sometimes they exist 3 atoms making up a molecule. So oxygen, hydrogen, nitrogen, chlorine, fluorine, bromine. Some of the are the ones that exist as molecules. They don't exist alone. So oxygen, don't ever say sodium plus oxygen, then you write oxygen to just a O. No, it's wrong. Oxygen is a molecule. So we have to write it when they are paired. It's like hydrogen. To give us now, let's project, to give us sodium oxide, of course. Now, that sodium oxide, we learned in my previous lesson, you will check it, how to write chemical formulas. So, sodium oxide. Sodium oxide is a solid. It's white in color. Now, let's look at it. Now, we have given the state symbols, but we have not balanced the equation. Sodium in the product side is 1. In the reactant side it is 1. In the product side it is 2. So I will put 2 here. So when balancing chemical equations, don't put the number you are fixing in front, after the chemical symbol of the element, no, or the compound. You put it in front of it, so that it cuts across everything. Now, after putting 2 here, then sodium becomes 2. It is 2. Now oxygen, it is 2, it is 1. What do? We have to balance by putting 2 on sodium oxide so that oxygen becomes 2. If I put 2 here, guess what? It changes the number of sodium atoms. Now oxygen is balancing. It is 2 in the reactant side, 2 in the product side. But by putting 2 here, it affects our number of sodium atoms. Now it's 4 here. I do what? I go back. Then I write 4. Anytime you are balancing a chemical equation, unless you are sure of what you are doing, start using a pencil. After you have balanced it now, write it. If you want to use a ink pen. As simple as that, that is how it should be. So you see, it is balanced. I know the product form, the state symbols are there. That is okay. I will just write few examples. This is one of them. By the time I'm in my 5th one, you will be okay to start others. Water is an oxide of hydrogen. Accept it or you reject it. Hydrogen, gas, plus oxygen, gas, give water. It is a liquid. Now, how can we balance this? Hydrogen 2, hydrogen 2. Hiyo tuacha nayo. Twende oxygen 2, 1. That means you will have to put 2 here. By putting 2 here, it changes the number of hydrogen atoms. It becomes 4. 2 times 2. Just like in the sodium, 2 times 2 becomes 4. So 2 times 2, 4. I just put my 4 here. The equation is very well balanced. Nice. Let's move to the third one. A metal and acid. Calcium, solid. Which acid do you want us to use? It's actually the one you are thinking of. Aqueous. To give us, before we project the products, sulfuric 6 acid. Whenever you see when it is aqueous, I say it means it is a solution. So, sulfuric 6 acid in form of aqueous, it means it is dilute sulfuric 6 acid. If I was using concentrated sulfuric 6 acid, it could be liquid. But now, because it is dilute, it's aqueous. That is it. So now, let's project what's being formed. It's a metal and an acid, a salt and hydrogen. Which salt? Calcium sulfate. Then hydrogen gas. Calcium sulfate. Calcium sulfate. Calcium sulfate itself is insoluble in water. I will write that solid. To give the I mean plus hydrogen gas. Get this. So the remaining is, we check whether it's balanced. Sometimes you write an equation, then God comes in and tells you the equation is balanced. Let's see if God is there for us. Calcium and calcium are 1. Hydrogen here, 2. Hydrogen 2. Sulfur, don't balance sulfate, you balance sulfur. 1, 1. Oxygen 4, oxygen 4. God has always been on our side. And we have balanced the equation. Yes. You cannot be able to balance life if you can't balance simple equations. Start by balancing chemical equations so that you can balance life. Now, after this, let's look at a base and an acid. A base and an acid. Which base do you want us to use? Metal oxides, when dissolved in water, they give us bases. As far as the metal oxide is soluble in water, like sodium oxide, potassium oxide, calcium oxide, magnesium oxide, those are the ones which are soluble in water. Then, when you get a metal oxide and a dilute acid, the water in the acid, because of it dilute, will now make the metal oxide to be as if now it is being diluted in water, or you have added water to it. So, though I'm writing sodium oxide, but it is the same way sodium hydroxide reacts. So, let me use calcium oxide as solid. Now I want to challenge you. Can you go and research all the colors of metal oxides? You can't be doing that research. Who has scored many goals this season? Who has done what? But you can't do a research on what's the color of calcium oxide. That is nitric acid. Calcium oxide, nitric acid, a base and an acid. If I use here a base that is not soluble in water, let me tell you, there will be no reaction. For example, copper 2 oxide. Copper 2 oxide is insoluble in water, so it will never display the basic properties. Now this one, acid and a base, when acid and a base are reacting, we call the reaction a neutralization process, because the acid and the base are neutralizing each other. So it's going to give us neutral products, water and salt. Always water as a pH of 7, salt as a pH of 7. The salt here is calcium and nitrate. Calcium nitrate appears. I still challenge you as usual. Please know how to write chemical formulas. Plus water, liquid. You know, when you get used to these things, my hand will never rise up from a board or from a book without writing the state symbols. Just writing water, the hand knows very well, I'm supposed to write liquid after this. Now you go learn until your hand and the brain will coordinate you. There is something you have not written. Yes. Okay, let's balance this. Calcium 1 on the other side. We just leave it. I'm not saying it's balanced. We will continue. We will know it later on. Oxygen here is 1 plus 3 here. It gives us 4. Oxygen here, 2 times 3, 6. 6 plus 1, 7. So what can we do? If I put 2 here, 2 times 3, 6 plus 1, 7. Oxygen already is balancing. It's always very simple. When you look at me doing it, it's very simple. Also do it in your book. It's simple until it comes during the time of exams. Then you console yourself after the exams that the good thing is I'm out of the exams when I'm alive. So oxygen is balanced. Now, calcium is also balanced. Let's look at hydrogen. Hydrogen here we have two hydrogen. That's it. You can also see 2. So that is balanced. Let's look at nitrogen. This 2 is for the whole of the acid. See hydrogen pekee hapana ni yote. Ni hii. So 2 nitrogen. Now look here. These 2 are because they are in bracket. These 2, it's only for oxygen and nitrogen because that is what is in bracket. This 3 is only for oxygen. So the nitrogen is 2 times 1, which is or just 2 for nitrogen. And it is 2 here. So the equation is balanced. As simple as that. As simple as 1 to 3. As simple as telling a lie. Equal to. I want us to look at another one. many others. Let's look at between a metal and water. A metal. I don't know why I love calcium. And because I love calcium, look for your metal that your brain loves. Plus water. Give us calcium hydroxide plus hydrogen gas. Then a metal and the acid will give us a salt and hydrogen gas. So the two of them produce hydrogen gas, but during preparation of hydrogen gas, we don't pick this. It gives less hydrogen. It takes longer time. So we pick a metal and acid to prepare hydrogen gas because it gives a large amount. The hydrogen in water is displaced fully. Yes. So this one will give us calcium hydroxide. Remember chemical formulas. Aqueous plus hydrogen gas. That is it. What is it remaining now? Balancing. Calcium 1, calcium 1. Hydrogen 2, hydrogen 4. 2 here and 2, 4. Nikiweka hapa 4. I mean nikiweka hapa 2. Now we have balanced the hydrogen. Tumeongezea oxygen ikuwe 2. Angalia huko kama oxygen 2 ni 2. The equation is balanced. You know, it is very simple because I know how to project what are the products. I know how to balance. Very simple things. You know, make them your friends. And actually you love chemistry. The other thing is, let's pick a metal and a steam. Steam is simply water in a gaseous form or in a gaseous state. When you open a souffleur, when you are cooking, unfortunately most of high school students nowadays, they don't know how to cook, even you. So metals like copper, iron, that do not react with water, cold water, they do so with steam. And even any other metal, even calcium with steam. But now the products here will change. It will not give us calcium hydroxide, it will give us calcium oxide. Calcium oxide. So calcium, solid, plus steam. How do you know that it is a steam? Look at the state symbols. Gas, solid. So it will give us calcium oxide plus hydrogen gas. This is a solid. Very solid. Plus hydrogen gas. I almost behaved like some of you. Then there, what follows is we balance the equation. The only thing someone knows how to balance is but to balance the ball. Anyway, calcium 1, calcium iko sawa, hydrogen iko fiti kabisa, oxygen. That question, God came for your rescue. In case you have to write that question, that is when now you know that God is there and has come for your rescue. The last equation, so that now you can go and also practice yours. Iron plus steam. Iron reacts with steam to give us in a special case. And please be very careful with special case situations like iron and steam. The others give a normal oxide. Now iron reacts with steam kuna kitu inaitwa tri-ion tetra oxide. Tri for 3, tetra for 4. So tri 3 ions, 4 oxygen atoms. Plus hydrogen gas. As simple as that. Hii ndio inaitwa tri-ion tetroxide. Najua ujui, lakini sasa kila mtu lazima atoke mahali ajue. Sasa leo umejua. Ion is 1. Ion is 3. Balance. Ngendanga hoteli na mtu mnapanga niko na ngapi, mna balance. 3. Umetoa 200, toa 200 hata wewe. Hydrogen 2. Kwa ni 2. Sasa maneno oxygen inaharibu maneno. Napanga deal vizuri, ati sijui mnataka mwende wapi. Mwingine anawaambia mamangu ameniambia nikitoka nyumbani ataniua. Huyo sasa ndio hiyo oxygen sasa. Hii ingine ina balance, hii oxygen imekataa balance. So now hydrogen ni 2, hydrogen ni 2, yes. Lakini huyu amenyima atoke nyumbani. Sasa oxygen ni 4, hapa ni 1. What can I do? It's what actually you are thinking of. Do oxygen equal 4? Naweka hapa 4. Now it's 4. Lakini hydrogen imekuwa 8. Sasa ndio hydrogen pia equal 8. Tunaweka hapa 4. Si imebalance. So what else do you want? Those are the equations. I will still have another session. Just click on the next video. You check other examples of writing this. It's my pleasure that you also move ahead in chemistry. Please get an A. Get a good A. Then I'll be happy. Any question you can drop at the comment section. Any query, ask. I will answer you. Thank you. Hope the lesson was successful. Hope you have learned something. God bless you.